So suppose I have this plane, which I'm going to identify as being x plus y plus z equals 6, and I have 2 points, P and Q, and what I'm interested in is where this line, the line that goes through points P and Q, actually intersect the plane. Well, the first thing I'm going to do is I'm going to identify a couple of vectors here. So I'm going to let R naught, this could be the position vector for point P. So R naught's going to be 1, 0, 1. And I'm going to let R be the position vector for point Q. So that's 4, negative 2, 2. And I'm going to take A, and I'm going to let A equal R minus R naught, which is simply going to be equal to, 4 minus 1, negative 2 minus 0, 2 minus 1, which is, 3, negative 2, 1. And so A actually has representation PQ. So vector A is actually going to be our direction vector. Whoops, ION. So obviously what I'm doing first here, I'm going to try to figure out what the equation of this line is that passed through these points to begin with. Okay, so the line is then going to be R naught plus T times A. This is going to be the equation, the vector equation of our line. And that's obviously going to be 1, 0, 1 plus T times 3 minus 2, 1. And that would then give me then, in parametric form, that x equals 1 plus 3t. Whoops. 3t. Y equals a negative 2t. And z is equal to 1 plus t. Oh, I don't know why I keep writing 2's rather than t's. It's been one of those days. Okay, so 1 plus t. Now this is x, y, and z. It's the same x, y, z that's in my plane. So if I substitute these into the equation for the plane, I will get 1 plus 3t. There we go again. 3t minus 2t plus 1 plus t is equal to 6. So now I need to start doing a little bit of algebra here. See, I've got 3t minus t plus t. That's just going to be 2t. And I have the constants 2, so 2 plus 2t equals 6. That implies 2t equals 4, which implies t equals 2. Now, what good did that do me? Well, that told me at what, now if I'm thinking in terms of time, but what value this parameter t for the equation of the line that I will be in contact with the plane. So now if I go back in and say, okay, t equals 2, I substitute this back in to my parametric equation for the line, what I end up with is that x equals 1 plus 3 times 2, which is 7. Y equals negative 2 times 2, which is negative 4. And z equals 1 plus 2, which is 3. So where does the line that passes through these 2 points intersect the plane x plus y plus z equals 6? It happens at the coordinates 7, negative 4, and 3.